Hiding complexity with facades. Introduction to facades. In this video, we are going to discuss the facade pattern by examining the current state of the sample application. You will see the mechanics of what this pattern is really all about through examples. We will also weigh what kind of benefits and drawbacks using this pattern can bring into your codebase. Let's get started. Alright. To start off with, let me just say that you have already used the facade pattern yourself to some extent, and it's already present in our sample codebase as well, to some extent as well. Let's see where. Consider the add-order method in the warehouse class. It does quite a lot of useful things for us. First, it validates preconditions. Next, it fetches a customer object. It then validates what was retrieved. It then fetches products, validates their existence, and makes sure there is enough of them in stock. It updates the available stock, creates the order object, and finally, it places an order. It's a whole lot. This method, add-order, in the warehouse class is invoked from two places in the codebase. The two call sites are located in CLI and in the web class. There are other usages among the classes, but those are unrelated to our topic. In the CLI class, the add-order method is called after gathering lots of user input regarding what kind and how many products to order. Similar things happen in the web class as well. User input is extracted from a web request. Let's see what is a facade and what isn't in this scenario. The warehouse class is our facade in this scenario. It is a simplified interface in front of other subsystems in our codebase. By subsystem, when talking about the facade pattern, we mean other classes in our codebase which provide some useful facilities, like DAO classes or data classes like order or customer. The warehouse class's add-order method encapsulates the complexity of using other subsystems to provide the functionality to add new orders to the system. The CLI and web classes are the clients in our case who need functionality like what the add-order method provides. In this case, the clients CLI and web depend on these subsystems indirectly through the warehouse class, our facade. Without a class like a warehouse in between the clients and other subsystems, there would be a direct dependency between the objects. If we eliminate or don't create a facade class like warehouse to begin with, then the clients must depend and use directly the subsystems in question to achieve the same set of functionality. By indirect connection between clients and subsystems, through the warehouse class's add-order method, we gain several benefits. The client classes benefit from ease of use since they don't need to recreate the logic encapsulated into add-order. To add a new order to the system, one would execute statements in a certain order as implemented in the add-order method. Clients can either depend on the facade's add-order method, a single method on a class, or depend directly on the subsystem classes and re-implement the steps themselves. The goal of facades is to provide a simplified interface for clients who don't want to deal with the added complexity of relying on the subsystems themselves. Clients, by relying on a single facade class instead of multiple subsystems, can benefit from having reduced coupling to the subsystems and how they are implemented. When depending on a facade, a client only knows the minimal amount of information that is necessary to access a feature and doesn't care about how that feature is implemented. The benefit of this is that how the feature is implemented can change without affecting the code of the client. We would replace all this with new subsystem classes doing completely different things. The client wouldn't know or care. The facade pattern basically forces developers to consider code reuse and rely on encapsulation. This is useful when you have a code base where lots of client classes use other subsystems to achieve the same thing, each doing the same thing but just slightly different compared to other classes. This is when errors creep into a code base, which is hard to track and fix. Keeping the situation in check by hiding complex usage scenarios under facades can help a lot. The facade pattern is a structural pattern, and there is nothing complex to it once you start using it. The basic idea only uses techniques or concepts like delegation and composition. Hence the statement from before, you already use this pattern to some extent.